We'll now take a look at a different set of operators, which are what we call logical operators. So far, we've discussed about how we can perform a single comparison between two values, or two integers, two doubles, two characters, or some combination of them. But what if we want to perform multiple comparisons? What if I want to check if x is less than y, and then also check if y is less than z, something along those lines? Well, we can use the logical or Boolean operators to combine logical expressions. There are three such operators. We have the not operator, which is just an exclamation point. We have the and operator, which uses two ampersand symbols. And then we have the or operator, which uses two vertical bars. If you don't know where the vertical bar is, take a look at the enter key on your keyboard, look at the key directly above it, and it's a shift, and then that key right there, that gives you the vertical bar. And we're going to take a look at all three of these in more detail. For the not operator, we place a exclamation point in front of our logical expression, and this just simply reverses the value of that expression. So for an example, let's say we have some expression a. So a we're just labeling as some logical expression. So we can use what we call a truth table to look at all possible outcomes for a logical expression. So here's an example of our truth table. So let's say we have the expression a on the left-hand side, and the only possible values we can have for a are true and false. So if a is true, then not a is false. And likewise, if a is false, then not a is true. So we just look at the respective columns for a particular row. So let's take a look at a simple example. So let's say I have not and then the expression 5 less than 6. Well, 5 less than 6 is true, so we evaluate that part first, and then the not true would evaluate to false. Now, the not operator only required a single logical expression. The other one, so like the and operator here, requires two logical expressions. And here's how it works. If both expressions are true, then the whole combined expression is true. But even if one expression is false, then the entire thing is false. So it's an all or nothing deal. Either every single thing has to be true in order for it to be true, but even if just one thing is false, then the entire expression is false. So let's take a look at a truth table and let a and b be our logical expressions for this example. So if both a and b are true, then a and b is true. So we can see that from the first row. But notice in the other three rows, at least one of the expressions, a or b, or even both, is false, which means the entire thing is false. So if a is true and b is false, then a and b is false. If a is false, b is true, that means a and b must be false. And then, of course, if a is false and b is false, there's no way that could be true. So a and b are definitely going to be false. So let's take a look at an example. So let's say we have the expressions 14 greater than or equal to 5, and then capital A less than capital B. So we're combining these two with the AND operator, and we want to check if the whole thing is true or false. Well, 14 greater than or equal to 5, that part is true. And capital A less than capital B, that's also true. If you do the collating sequences and compare them, that's going to be true. So since both of these expressions are true, then when you combine them with the AND operator, it must also evaluate the true. Now the OR operator also takes two logical expressions, just like the AND operator. And this kind of does the exact opposite of the AND. So if at least one expression is true, then the whole thing is true. I can have like everything else be false, but as long as one thing is true, the whole combined expression is considered true. Now, if all the expressions, or in this case, since we're really only dealing with two, if both of the expressions are false, then the whole expression is false. So let's use A and B again as our example. So if A is true and B is true, then obviously A or B will be true. If A is true and B is false, since one of these two is at least true, then A or B is true. If A is false and B is true, once again, at least one of these is true, so A or B is true. But if A is false and B is false, then A or B must also be false. So let's take a look at an example here. So this is slightly different from our previous example. So I'm still comparing 14 greater than or equal to 5, but then I'm also checking if capital A is greater than capital B. Well, 14 greater than or equal to 5, that's still true, but capital A greater than capital B is false. But since we're checking if at least one of these is true, so since we have true or false, this thing's going to evaluate the true. So now we actually have several different types of operators. So we have arithmetic operators, relational operators, we have logical operators. So we kind of need to take a look at the order of precedence, because if we have all these combined in a single statement, which ones do we evaluate first? I mean, we know we should do multiplication, division over addition and subtraction, but what about the logical or relational operators? So let's take a look at the precedence of operators. So the first precedence is going to be the unary operators. So the not operator, the positive values, although the plus sign is normally not used for unary operators, but the negation symbol would be one that we use. So basically the not and the negation operators would be the first ones we deal with. Then comes the multiplication, division, and modulus operators, followed by addition and subtraction. Then we take care of the relational operators. Okay, now here we divide the relational operators into two parts. Here we're talking about less than or equal to, greater than or equal to, and greater than. Checking for equality comes next. So if we have something that involves both relational and equality type operators, we deal with the relational ones first. Then we check if values are equal to each other or not equal to each other. And then we'll take care of the AND operator, and then the OR operator, and then finally we would take care of the assignment operator if that's included in our statement. So let's do an example here just to kind of show how all this comes together. So here's a lovely expression. So we have 17 less than 4 times 3 plus 5, or 8 times 2 is equal to 4 times 4, and not 3 plus 3 equals 6. So let's take care of each of these parts, and we'll try to do a couple steps simultaneously just to save some space. So for the first part, the 17 less than 4 times 3 plus 5, we can handle the multiplication part of it first. That has a higher precedence, so we can do the 4 times 3. The second expression, we can take care of the multiplication on both sides. And then in the last expression, addition is actually higher in the precedence. You might think, well, wait a minute, we have the negation part where we have the not operator, but that's outside the parentheses. We've got to take care of what's in the parentheses first. So this turns into 17 less than 12 plus 5, or 16 is equal to 16, and not the case that 6 is equal to 6. Okay, well, we can then take a look at each part and handle the next level precedence. So in our first expression, the addition comes before the less than symbol, so we can do 12 plus 5, which will give us 17. We can go ahead and evaluate the equality for 16 equals to 16. That's going to be true. And then we can evaluate the equality in the 6 equals 6 line. That's also going to be true. So now we have 17 less than 17, or true and not true. Okay, well, 17 less than 17 is false because 17 is not less than 17. It's equal to, sorry. The true part has already been evaluated for our middle expression. The right expression, well, not true, is going to be false. So now we get false or true and false. Now, so we have the OR operator and we have the AND operator. So remember, the AND is going to be evaluated before the OR. So that means that we evaluate this part right here. We evaluate this part because remember, AND comes before OR. So true and false is going to be false. So now we get false or false, which since both of these are false, this whole thing evaluates to false. The last thing we're going to mention is that if we're going to be dealing with these different types of Boolean logical expressions, that we can use a Boolean data type to store Boolean values. So maybe we do some expression and it evaluates to true or false. Maybe we want to store that result in some variable. So like for example, let's say we have the lines of code Boolean legal age. So legal age is going to be equal to either true or false. And then we have the statement legal age equals age greater than or equal to 21. So what this is saying is if the value of age is greater than or equal to 21, that's going to evaluate to true, and that's going to be stored in legal age. So legal age would store true. Now, if age is strictly less than 21, then age greater than or equal to 21 is going to evaluate to false, and we store false in legal age.